In this video, we'll look at calculating the pH of a strong base. We're only going to look at strong bases in this first year course. We'll save the weak acids and weak bases for another course. Now, first I need to recognize that it is a base. Sodium hydroxide will dissociate to produce hydroxide ions. I'll get sodium and hydroxide ions. That's the first thing you got to tackle is recognizing that it is a base. Now, when we look at just strong bases, you'll see hydroxide at the end of the formula. There are some weak bases that are a little funky where they might not be the direct source of hydroxide. It might be coming from a reaction with water, but the strong bases will end with OH. And by saying that it's strong, we also mean that this happens 100%. 100% dissociation. So that's similar with the acid. If the concentration was 0.0005, there were 0.0005 moles of sodium hydroxide in a liter of solution. It dissociates fully. I'm going to get 0.0005 moles of sodium and 0.0005 moles of hydroxide. Now, in the end, the sodium is just kind of hanging out. The sodium is not acid, it's not base, it doesn't produce hydrogen or hydroxide. We essentially call it a spectator ion. The sodium is there, but it's not doing anything. In the world of acids and bases, the ion that I'm more concerned with here is the hydroxide. And if I know it's strong, then the concentration of the original NaOH is the same as the concentration of the individual hydroxide ions. Okay, cool. So now we have a little problem. When I calculate pH, it's opposite log of the hydrogen concentration, hydrogen or hydronium. And I don't have that. I have hydroxide. Dang it. But there is another equation. Do you remember this one? Hydrogen times hydroxide equals 10 to the negative 14th. For any solution, the product of the hydrogen ion concentration and the hydroxide ion concentration is 10 to the negative 14th. That's a constant, the 10 to the negative 14th. It's true for absolutely every solution. So then, if eventually I need the hydrogen concentration to do pH, but I have the hydroxide concentration here, I think we can make this work. We're just going to go back to this second equation, and we'll leave the hydrogen concentration as our variable, and then we'll plug in the concentration of the hydroxide. And together, they're 10 to the negative 14th. So I'm going to plug this in my calculator to solve for hydrogen. I'm going to go 10 to the negative 14th divided by 0.0005. And my calculator says about 2.0 times 10 to the negative 11th. It's probably something that you need to plug into your calculator at some point just to make sure that you're using your calculator's functions correctly. Are you using the caret key? Are you using the little EE exponent key to enter your scientific notation? But make sure that you get something close to 2 times 10 to the negative 11th. Which, now I can do pH. Now I can take this hydrogen concentration and plug it into the pH equation. pH is opposite log. Hydrogen is 2.0 times 10 to the negative 11. Now that number is crazy tiny, which kind of makes sense. Molar hydrogen, there we go. Because this is supposed to be a base. I mean, I can look at NaOH, and I know that in the end, my pH has to be something greater than 7. And in fact, I'm going to estimate that it's close to 11. If my calculator dies in the middle of the test and it's multiple choice, I'm going to pick something close to 11. pH should be the opposite exponent of 10. Now, it's not going to be exactly 11 because I don't have a 1 out in front. But if I plug this in, opposite log, 2 times 10 to the negative 11th, I get a pH of about 10.7. Seems reasonable to me. Now, if I had something like a pH of 3, that's a little crazy because this is a base. When I see hydroxide in the formula, it's a base. And if you've got a pH of, again, like 38, that would be a little bit crazy too. So it should be something between 7 and 14. So a base just takes an extra step. I don't think it's hard. It's just an extra step. So even in this second one, as long as I know this is a base, I'm going to have to calculate the hydrogen concentration. I'm given the hydroxide. This 2.80 times 10 to the negative 4th, that will be the OH hydroxide concentration, because this solution is sodium hydroxide. So I've got to be able to look at my solution and at least identify if initially it's an acid or a base. Does it start with hydrogen or does it end with hydroxide? Because we will only calculate pH for strong acids and strong bases. So that makes things a lot easier. The product of the two is always 10 to the negative 14th. Hydrogen equals, now again, you got to try this in your calculator. With all this scientific notation, make sure that you're doing order of operations correctly for your particular calculator. I'm going to go 10 to the negative 14th divided by 2.80 times 10 to the negative 4th. And in my calculator, I'm getting about 3.57 times 10 to the negative 11. If you're not getting that, a couple things to try. If you're obsessed with the caret key and you're going like 2.80 times 10 caret negative 4, it's okay. But when you start doing like further calculations, you might need to put this in parentheses. Like you might want to put these two quantities in parentheses so that your calculator knows that it's two separate quantities that you want to divide. Otherwise, you might plug in 10 caret negative 14. So your calculator says 10 to the negative 14th. And then you say divided by 2.80. So your calculator divides by 2.80. Then you say times 10. Your calculator multiplies that times 10. Then you plug in like caret negative 4th, and your calculator raises that to like the negative 4th power, and you get something super wacky. And it's really just an order of operations issue that we want to tell the calculator that these are two quantities. They're scientific notation quantities. The other option is to use that exponent key, that you could plug this in as like 2.80, and then you've got that EE key. It's usually a second function. Then all you have to do is tell the calculator the exponent, negative 4. That key is specifically meant to be used for scientific notation. So when you hit that key, your calculator says times 10 to the what? And you just have to tell it the exponent of 10. You do not need to put in times 10. So you don't go like 2.80 times 10 and then EE negative 4. That would be sad face. This is happy face. That's how the first one, that's how I do it. That's how I always do my scientific notation. It's foolproof. I don't need parentheses because my calculator knows that it's scientific notation. But I get people are obsessed with that caret, and it's fine. You just know that you might need to put those quantities in parentheses. If you use the second one here, you're going to be off by a power of 10. It's just that you don't need to put in this times 10 to the when you use the EE key. Your calculator already knows that. So anyways, try it at some point just so that you know you're doing it right. But now once I know the hydrogen concentration, I can do pH. pH is opposite log of the 3.57 times 10 to the negative 11 molar hydrogen. And just like the previous question, I'm going to guess that my pH will be somewhere around 11. It won't be exactly 11 because, again, I don't have a 1 out in front, but it should be something close. And that's at least how I know that my answer is reasonable. So if I plug this in, opposite log, 3.57 times 10 to the negative 11, I'm getting a 10.4. In the ballpark of 11, and definitely something basic. So the answer is reasonable. The biggest error that people will make is that they just don't recognize that the initial solution is a base. That's the first problem. If you notice that it's a base, then you got to do that extra step to figure out the hydrogen concentration before you can do the pH. If it's like the previous questions where they gave you a solution of HCl, and you notice, oh yeah, HCl, that's an acid. It starts with hydrogen. Then you're off to the races. Plug it in, opposite log. But now we just have to take like 3 seconds to recognize, ooh, yep, that one's a base. Then I need the extra step.